Hello and Assalamualaikum. My name is Nur Aini Muhammad Sulaiman. I am a final year student of Computer Network and Security, and today I will run the demo on executing the experiment on profiling investment scam victims using textual analysis. And in this demo, I'll walk through the step involved in processing the data, and including how we extract and clean the article data, annotate it, and train the models to identify the key entities. And first and foremost, we need to collect articles related to investment scams from the website. And to do this, I will copy the URL of the article that I wanted to process and paste it into the Python code in this crawl and clean article.python. And this is the list of link that I wanted to extract. And the first and we go through the code one by one. So at the top, from newspaper import, the hey now let's take a look at the code. First, we import the article class from the newspaper library, which will help us extract the article content from the URLs. And we also import the NLTK library, which is used for natural language processing. And then the NLTK download punk method ensures that we have the necessary tokenizer, which is crucial for breaking down the text into sentences and words for further analysis. And then we have the URL list that holds the URLs of the articles we want to scrub. And we have the article download. This ensures to download the content of the article. And then we have article plus. This will parse the article's content. And then we have the NLP that applies the natural language processing to the article, allowing us to analyze the keywords and other relevant information. And with that being said, after running this code, the article will put into a folder. And then this is the folder that contains the clean article for annotation, and this is the article that I have been extracted. And if we look at into one sample, so this is the sample of the articles that have been cleaned. And we'll move to the annotation process. So we will be using the Brad tool for this, and we go through the process involved. And to start, we need to install the Brad annotation tool. And after installation, we need to run the following command. This command, python to standalone.py. Interface after we click on the local host. And then firstly, we have to sign up. So if we click at any of the word, so this is the predefined entities that I have set, and we have the state, location, platform, age, gender, and occupation. And since I click on the clerk, so the respective entities is the occupation, and then I click on occupation, and then I click OK. And then yeah, there will be showing the occupation clerk. And yeah, so actually when we annotate here in the folder of Brad and in the data and clean the articles annotation. This is actually the folder that I uploaded. And actually initially it just have the text file, but then after we have annotate the text file, then it will automatically create the annotation file and then store the annotation that we have done here. So this is actually the annotation that I've been doing. Yeah, so here is the latest one. After we have annotate the files, we will have two pair of files, which is the text file, which contain each word or token is saved with spaces, and it is exactly as it is appeared in the original article. And then we have the annotation file, which then contains the annotation for the article, which have four elements. First is the entity that we chose, that we have predefined, and then we have the where the the word start and where the word ends, and then this is the word. And yeah, same goes to all of this. So now that we have the text file and annotation files, we can convert the annotation into IOP format, which the IOP format is commonly used for training any R model, and where we tag the entities as B for the beginning of the entity, I for the inside the entity, and 0 for outside, O for outside an entity. And here's the Python code that takes the annotation and text file process them and convert the annotation into IOB format. And here is the load annotation. This function reads the annotation files which contain the entity annotation for each article. The entities, such as occupation locations, are stored with their start and end position in the text. And then the entity information is extracted from each line starting with T, which includes the entity type, such as occupation, and its start and end position in the text. So now we go to the get IOB token function, and this function actually will tokenize the text and assign the IOB text to each token based on the entity information. And if a token starts an entity span, for example, the beginning of an occupation like engineer, it gets a B tag. And if it's inside an entity, for example, senior engineer, it gets an I tag. Otherwise, it's taken as 0 for outside any entity. Next, we go to the read to IOB function that process each text file and annotation file pair in the given folder, and it converts the annotation into IOB format and writes the result into new file, which is output IOB files folder. And yeah, it appends each file's content with a new line in between. So after we run the back to IOB, it will have the folder which contain all of the IOB tag from the articles. But then we will combine all of the IOB files into one single files to become the dataset. Then which then become the annotated corpus that we wanted to achieve for the objective for the first phase and the first objective of our research. So this is the sample or the snippet of the output IOB text file, which contain the IOB formatted dataset. And this is actually containing all of the approximately 300 articles, which then have the every sentences is being considered as a token or words, and every words will have their respective label or tag. For example, the other is labeled as O or outside of the entity. And but here the maintenance supervisor, we tag them as a occupation, and then we have the maintenance as the B occupation, the beginning of the occupation, and supervisor as the intermediate or intermediate of occupation. And there's much more that we have annotated. So yeah. Now that we have the annotated corpus or the dataset that will be used in training and testing the machine learning, so we will go through first the process of how the hidden Markov model (HMM) works for training and evaluating entity recognition. So the first step is to read IOB data using the read IOB function, and this function splits the text into words and associates each word with its corresponding tag, such as p location or igender, and this make the data ready for the model to use during the training and evaluation. So once the model has met the process, we need to evaluate its performance. The calculate metric function here comes to the role. It calculates precision recall and affine scores for each entity type, and this function compares predicted labels with the true labels using precision recall F-core support function from sklearn to compute the metrics. To understand the results, the print metrics function prints out an evaluation report, and this includes precision recall and F1 score for each entity type, such as BH or B gender or I gender. Yeah, it also calculates the mark here. So it also calculates the macro average and weight average, which helps summarize the model's performance across all entities. Additionally, it prints the overall accuracy of the model. Next, we use the hidden Markov model. Next, we use the hidden Markov model trainer from NLTK to train the HMM model. The model is trained on the training data, which consists of annotated sentences in IOB format. This is actually I forgot to mention that we need to split data set into 70 to 30, which means 70% for training the data and the 30% left for testing the data. So the model is trained on the training data, which consists of annotated sentences in IOB format. And after training, the model is ready to make predictions on new or unseen data. After the model is trained, we test it on the test set. And the model predicts the level for each sentence, and we compare these predictions to the true levels in the test set. Finally, we calculate the evaluation metrics. Finally, we calculate the evaluation metrics and print them out. The precision, recall, and F1 score for each entity type give us clear picture of how well the model is performing. So now we're going to run the code by using this command, Python 3 new HMM train. So after we run the HMM Python file, we can we can see the total of sentence that has been extracted is 281, and the tokens is 43725. Um, and yeah, so this is the evaluation metrics that has been resulted of the running the after running the HMM training and testing. And for the precision and recall, let's take the B location entity. As an example, the model has a perfect precision of 1.00, meaning it correctly identifies all the location entities. However, the recall is 0.787, indicating that it missed some location entities in the text. This shows that while the model performs very well at identifying locations when it predicts them, it still misses a few. Looking at the F1 score, location has a F1 score of 0.881. This is a good balance between precision and a recall, meaning the model does a good job at both identifying locations accurately and capturing most of the location entities. And on the other hand, the iGender and iPlatform, is scores at the lowest 0.00, which means that the model completely failed to detect these entities. This indicates that the model struggles with identifying gender and platform entities, possibly because the entities were underrepresented on the training data or were difficult to distinguish from the entities. And finally, the weight average F1 score of 0.89 give us the overall performance of the model, taking into account the frequency of each entity type. And this score shows that on average, the model performs quite well when considering how often each entity appears in the data. Now that we will run the CRF with IOB file, it may take a little bit longer, but then it's actually HMM takes longer execution time rather than CRF.